Hey guys, Mr. Marone here. Welcome back. Today we're going to talk about trigonometry. It's the first thing we're going to really focus on after we do special right triangles, and we're going to be here for a little bit, so it should be something that will become fairly familiar with you as you go through. So the first thing we need to do is answer the question, what is trigonometry? And simply put, it's the study of triangle measurement. So it's when we are looking for specific side lengths of a triangle when we're only given a small amount of information. We were able to find side lengths given um, two other side lengths, but now we're going to be able to do it with sides and angles in a comparison. And we've got three ratios we're going to work with. So remember, a ratio is a comparison of two values. Okay, we have sine, we have cosine, and we have tangent. And they're abbreviated by their first three letters in each name. So you've got sine, S-I-N, cosine is C-O-S, and tangent is T-A-N. Okay, so that's where you're going to see the abbreviations as you see on the right-hand side. Now, we always reference it in terms of an angle. So if you look over here where we're saying sine of A, we said that the ratio of sine is the leg opposite to the angle over the hypotenuse. So if I'm at angle A, if I just draw a stick figure at angle A, okay, there's angle A. If I'm looking straight across, this is opposite. Okay, this is my hypotenuse because it's always across from the right angle. And that means this last side is what we call the adjacent side, and I abbreviate that ADJ. Okay, so if we were to look just from angle A, the sine is the opposite side over the hypotenuse, or in this case, side A over side C. Okay. If we were to look at the cosine of this, that's the adjacent side over the hypotenuse, so side B over side C. And then our tangent is the opposite side over the adjacent side, so that would be side A over B. Move that, if we were to move that stick figure now to angle B, okay, so our focal point is angle B, there's my stick figure, the opposite side is now going to be straight across from it, and it's going to be side B. So my opposite side's here. My hypotenuse doesn't change, that's always across from the right angle, and my adjacent side is the last side in the labeling. So if we were to look at sine from angle B, we've got B over C. For cosine, for our adjacent over hypotenuse, we've got A over C. And for my tangent, we've got B over A. So if you notice, the cosine of A is the same thing as the sine of B, and the sine of A is the same thing as cosine of B. So they kind of flip-flop back and forth here. And our tangent, the fraction just becomes the reciprocal when we change our focal point. So now let's just take one more reminder here, and we've got a shortcut way of remembering this. We use the phrase SOHCAHTOA, S-O-H-C-A-H-T-O-A, SOHCAHTOA. And that means it's the first letter in the ratio. So the first three refers to the sine, which is opposite over hypotenuse. Okay, S-O-H. Cosine is adjacent over hypotenuse, and my tangent is opposite over adjacent. Okay. Now, there's a collection of different ways that we can use these ratios. These ratios are not going to change the rest of the time. So if you memorize that little strip right there, SOHCAHTOA with those three ratios, you've got everything there is in regards to the formulas for this entire section that we'll be on for a bunch of days here. So make sure that you're starting to memorize those formulas. So the first and the most basic way that we see these used is when we're just writing the ratios. So if I'm looking at this figure, I'm going to do A first, and then I'll move my positioning. If you haven't noticed already, I tend to draw a stick figure whenever I'm doing this. So if we're looking from angle A, I want my reference point at angle A. And straight across from angle A is my opposite side. Okay? Straight across from the right angle is my hypotenuse. And then my last side is my adjacent side. Okay? So I've got my triangle labeled for angle A. Now we said in sine, it was the opposite side over the hypotenuse. Well, my opposite side here was 5, and my hypotenuse was 13. So the sine of A is just 5 over 13. We're just writing the ratio. For cosine, same thing, we're going to do our adjacent side, which is 12, over my hypotenuse, which is 13. And my tangent is always my opposite, which in this case is 5, over my adjacent, which is 12. We move our focal point to angle C here. The sine of C will count my opposite side over my hypotenuse, which is across from the right angle. And I have my adjacent side here. So sine of C is the opposite side, 12, over my hypotenuse, which is 13. Cosine, we said, was adjacent over hypotenuse, so in this case it will be 5 over 13. And finally, the tangent is the opposite side, 12, over the adjacent side, 5. Couple things to note here before we move on. You've got fractions for cosine and sine that are always going to be less than 1. Okay, those won't change. Those will always have a value of less than 1. Tangent is the only one where when you compare the ratio, it could have a value of more than 1, like we see in tangent of C here with 12 over 5. Okay, so just keep that in mind, that that's the only place that you can have a ratio greater than 1 when we deal with trigonometric ratios where all the sides have been given. Now let's take a look at two different cases that we're going to see where we're actually going to have to solve using trigonometry. So the first thing you're going to do in any one of these problems is find your focal point. The angle that we're going to reference is always going to either be one of the two angles that's not the right angle. So in this case, they gave us this 28-degree angle here. So that's going to be my focal point. I'm going to place my stick figure at that angle. Okay? And then I'm going to draw across and say this is my opposite side. And I'm going to draw across for my right angle. This is my hypotenuse. And then I've got my adjacent side here. Okay? Now, we determine which ratio to use by the information given to us. In this case, they only gave us information at the opposite side and at the hypotenuse. So we've got information here. Come on. We've got information at opposite and hypotenuse. So we're going to use sine. So we're going to fill in the information. If my formula was sine of x equals opposite over hypotenuse, my angle is 28 degrees. So I've got sine of 28, the angle measure, equals the opposite side, which is x, over my hypotenuse, which is 19. Okay, now, one thing to note, the sine of 28, that part on the left-hand side is simply a number. That's all we have there is just a number. It's usually going to be brought out to 4 decimal places, but it's just there as a placeholder. Just like when we dealt with radicals, radical 2 is just a number. Okay, so we're going to solve this just like anything else. In order to get x on its own, we've got to multiply both sides by that denominator. This is going to be a common theme. You're going to be doing this often. Okay, so we'll multiply both sides by 19. So I have x equals 19 times the sine of 28. Okay, and at this point, you can go to the calculator. The big key to this is to make sure that your calculator is in degree mode. You do that by clicking the math button, the mode button, and the third option down, it should have radian highlighted. You're going to want to highlight degree. Okay, make sure that you do this. And I'll post another video of how to switch that over, hopefully in the coming days here. But at this point, we're just going to evaluate this. We're going to plug this into our calculator and see what we get. And 19 times the sine of 28 degrees is going to give me, x is going to equal 8.92. We're going to round to 2 decimal places here. Okay? And that's all there is to solving it. If you notice, it was one step. We multiplied both sides by 19. Beyond that, it was just using a calculator. So when you've got x is the numerator, the value we're looking for is the numerator in your ratio, it's very easy. It's one step. Okay? The second case that we'll look at, and these are the two that you'll work with today, are when x is the numerator, and then case 2 when x is the denominator. So in this picture here, we've got our 33-degree angle here. That's our focal point. So I'm going to put my stick figure there. Straight across from that's my opposite side. Straight across from the right angle is my hypotenuse, and then I've got my adjacent side here. Okay. So once again, they gave us information at opposite and at hypotenuse. So we're going to use sine. So it's going to be sine of my angle equals the opposite side over the hypotenuse. And if we plug in, we've got sine of 33 equals my opposite side, which is 15, over my hypotenuse, which is x. Now, in order to do this, it's two steps. First step is to multiply both sides by the denominator, get rid of that fraction. We're just going to move x across. So I've got x times the sine of 33 equals 15. I'm now going to get x on its own by dividing by sine of 33. Remember, these are just numbers. Sine of 33 is just a number. So I've got x equals 15 divided by the sine of 33. And at this point, plug this into your calculator. Okay, and we get 15 divided by the sine of 33. And we end up with x equaling 27.54. Okay. Now, if you left it as 15 over the sine of 33, it would be an exact answer. We like getting decimals for these. So decimals are your friend. You're going to see decimals a lot in this section. Okay. Hopefully this will get you started today while I'm not there. And then tomorrow we're really going to dive into this head first and make sure that we have a lot of recollection of this. All right. Have a great day. Make sure to ask any questions to the sub if you need to, or to Mr. D, and I will see you tomorrow.